P okay, this is K, and K is what? K is 0 and minus 3. Then that's the center M. And let me see what else is here. 0 and then theta. So we've got point O. And then M. Okay, we'll come back to the other one. So the first question, they were asking you to determine the gradient of this line SR. Okay, so this was going up all the way. This is R, and there's S somewhere this side. So we're getting the gradient of line SR. Okay, sorry guys, I'm struggling to share the question paper. I don't have it on my phone, so I was just gonna look at it from my phone. So we said getting the gradient of the line, M is change in Y over change in X, which is Y in this case is supposed to be Y2 minus Y1 over X2 minus X1. But can you see on the line SR, we are only given 1 point of contact. So we only know that. So, but then this is a gradient. So a gradient is always, this is a tangent. Tangent is always perpendicular to the radius. Radius is from the center to the circumference of the circle. So we know tangent is always perpendicular to the radius. And also we know that if we've got lines that are perpendicular to one another, their gradients, when you multiply them, they must give you -1. So let's get the gradient for line PK. Cool. So let's get gradient for line PK, because on PK, you see we've got 2 points that are known. So PK, we've got gradient will be M of P, Y, not M, sorry. YP minus YK over XP minus XK. Okay, so it's the change in Y over change in X. So what is the YP? YP is -3. No. YP is 5. YK is -3 over XP is -4 minus XK is 0. So we have 5 plus 3, which is giving us 8 over -4. So that gradient is -2. Okay. That's the gradient of PK. Now we want the gradient of SR. So gradient of SR, we're going to have M of SR times M of PK is supposed to give us -1 because these lines are perpendicular. So M of SR, we don't know. M of PK, we just found it is -2. When we multiply them, they're giving us -1. Therefore, M of SR is going to be -1 over -2, which is 1 over 2. So that is the gradient for line SR. Then the next question, after you got the gradient, the next question they were saying, find the equation of SR. Okay, once you've got the gradient, then you can find the equation. So equation of the line is y is mx plus c. And the m, we just found it now, is 1 over 2x plus c. And SR, it passes through point P, which is -4 and 5. So we take the coordinates of P and we substitute them on the equation of the line so that we can get the value of C. So y is 5, half x is -4 plus C. So which is 5 equals to, this 2 is 1 and 2 this side. So we have -2 plus C. And you see then our C is 7. Okay, if I'm making a mistake, please correct me. Sometimes I'm already tired at this time, so I miscalculate some numbers. Can you see now, therefore, the equation of line SR is going to be half x plus 7. Okay, so that is that. Now let's go back to, let me see what else they asked. So after getting the equation of the line, they're asking you to determine the equation of the circle in the form of x minus a squared plus y minus b squared is equals to r. So they want the equation of the circle. Let's clear here. When one is there. Okay, so let's clear here and see. Okay, so they want the equation of a circle in the form of x minus a squared plus y minus b squared is equals to r squared. Okay, and we had said this, the a and b are the coordinates of the center. These are the center points. Okay, so do we know coordinates of m? We don't know them yet. We don't know what are these coordinates. So we need to find those coordinates. And how can we find those coordinates? We already have the gradient for line PK. So gradient for PK, it was -2. Okay, so and PK is a straight line, therefore we're going to have mx plus c, which is giving us -2x plus c. I hope we're not going to get cut again. I'm seeing a message saying my network is bad. Then we take any point on line PK. So I will use k, point k, which is 0 and -3, to get the value of c. So y is -3, -2 into 0 plus c. So our c is -3. Therefore, the equation of the line PK will be -2x minus 3. Let me just make sure that I'm still on the right path so we don't. Why am I doing? Oh, I want the thingy. Point M. Okay, I missed an important item there. Okay, so we were not supposed to even go this far. But let me just put this somewhere, maybe we might need it. So equation of PR, let's just put it here, is y is equal to -2x minus 3. Maybe we might need it somewhere. Then let's go back here. So there was something called a midpoint. A midpoint is if you've got two line here, and then this is the midpoint. Can you see that from P to M? This is a radius. Let me change my color. This is a radius. From here to P is a radius. And from M to K is also a radius. So you see, therefore, that M is actually a midpoint. It's in the middle. So we can get the values of M by using that coordinates of a midpoint. So this is midpoint M. And coordinates of midpoint is Y. What are those coordinates again? We start with X. So it's XP plus XK over 2 and YP plus YK over 2. Those will be our coordinates. So XP is -4. Can you mute your mic? Okay, sorry about that. Someone is trying to connect. They can now. I won't be able to assist them. Now they're calling me. I won't be able to help them when I'm busy. So I've got XP is -4 plus 0, X, which is XK over 2, and the Y coordinates of P is 5 plus the one of K is -3 over 2. So these are giving us -2 and 1. Okay, I hope that's right. Let me just confirm with my answers before we go far with wrong things. So now we've got coordinates of M. So M is -2 and 1. Now let's find the equation of the circle now. So the equation of a circle is in this form. So let's substitute. We said A and B are the center points. We got our center points. Therefore, we're gonna have x minus -2 squared plus y minus 1 squared is equals to r squared. And what is our r? We need to find our r. Okay, so it's supposed to be r squared. So we have x plus 2 squared plus y minus 1 squared is equals to r squared. Let's find r. Can you see that r is the radius, which is the point between M and K, or the point between M and P? So then we can find our r. Okay. Now let's find r using the distance formula. So r squared is equals to x minus, what is that formula for r? Or for distance? Okay, let me go back here. Let's see. I should have something here. Just give me a moment. Let me get the pictures. It won't be here. Nope. Get it from the book. Now it's dark. I don't even like it. Oh, I can't see. Hey, sorry guys. I didn't know the Excel was gonna go away. So distance formula. Let me come back to your screen. Where am I now? Okay. Right. So the distance formula, AB, is a square root of y minus y2 minus y1 squared plus x2 minus x1 squared. Okay, so that's the distance formula. So now we're gonna use point M, which is -2 and 1, and point K, which is 0 and -3. Okay, so that's what we're gonna use. So y2 -3 minus y1 is 1 squared plus x2 is 0 minus -2 squared, and it's a square root. Therefore, we've got -1 minus 1 squared, which is -4 squared. -4 squared is 16 plus 0 minus -2, which is 0 plus 2 is 2 squared. 2 squared is 4. Then we've got square root of 20. So our r is square root of 20. Okay, let me confirm that. Yes, r is square root of 20. Therefore, if r is square root of 20, then the equation of the circle will be x plus 2 squared plus y minus 1, which is square root of 20. It's actually r is square root of 20, and r squared will be 20. So this will be equals to 20. That's the equation of the circle. Okay, then that is that one. Any questions, guys? So if you have a question, you're welcome to unmute and ask a question. We are not too many, so I'm sure we can handle the interaction. So anyone with a question? Nobody. Right, let's continue then. The next question, let me go back to the question paper. The last question from here was the size of R. Okay, let's see, let's leave that one for now. We will come back for that one. Okay, so let's move to the next question. Let's see, let me close this, stop sharing. Let me go back to the question paper. Jesus. Okay, let's see. What other question is related to analytical geometry? Let's check from my book because I'm really struggling. Sorry, guys. Now I can't see what's happening. Question 4.2. I think. Let's see. 4.2. Determine the value of T if the circle. Okay, and then calculate area of SMK. Let's see, did I get that one? Okay, get that one. Right, so the other ones I still need to figure them out on the paper. So, okay, so I'm gonna do that just on the analytical geometry. If you want me to do anything else on that one, then you are welcome to ask me any question. Otherwise, then let's move to Euclidean geometry. Are you guys still with me?
Yes, ma'am.
Okay, so no questions.
No, ma'am.
All right. Okay. Right. So let's move to Euclidean. I don't know how if we're gonna make it to 8 o'clock though, with my light that is dying. I'm struggling, really struggling to see what's happening. Anything else we can do here? Okay, let's do just example from my textbook and see. Save and clear. Okay, so you are given point A, which is, sure, guys, I'm having problems here. I can't see. Point A is 6 and 5. And point B is 0 and 7. Not 0, it's 10 and 7. And then, so they say point A and B are 2 points in a Cartesian plane. BA produced intersect the x-axis at D. AD is the diameter of the circle. So this is what you have, X and Y. And then you are given that this is this, C, and then this is G, this is O, this is A, 6 and 5, this is B, 10 and 7. Okay, so they say A, which is 6 and 5, and point B, which is 10 and 7, are 2 points in the Cartesian plane. BA produced intersect the x-axis at D. AD is a diameter of the circles centered at C. So C is the center. Okay, then question A, they say show that the equation of the line through A and B can be given as this. Show that the equation of the line through A and B can be given as 2y minus x minus 4 is equals to 0. Okay, equation of the line through A and B. Okay, let's see. We need to get that equation of a line. So through A and B, this is A and B, right? So we've got point A, 6 and 5. We've got point B, 10 and 7. Equation of a line, y is equals to mx plus c, right? We find m is y of b minus y of a divided by x of b minus x of a. Y of b is 7 minus that of a is 5, 10 minus 6, which is 2 over 4, which is half. So therefore, y is half x plus c. Okay, then we need to find c. We take any of those coordinates. Let's take those ones of a. Substitute them in here. So y is 5, half of 6 plus c. This is 3. So 5 minus 3 is c. C is going to be 2. Therefore, y is half x plus 2. Okay. Okay, they were saying prove that, show that it can be this. Let's see. Now we want everything to be on the right hand side. So first, let's multiply everything by 2. Okay, to get y to be 2, or to remove the denominator of the x. So we've got 2y is equals to x plus 4. Therefore, 2y minus x minus 4 is equals to 0. Okay, so that's that. Then question B, they say determine the coordinates of D. Okay, can you guys do that? I'm gonna give you guys 3 minutes. Coordinates of D. This is D. So can you guys do it? I believe you guys have you have your scribbling book. So can you get the coordinates of B? You've got the equation of the line. Because if this is the equation of the line, this is still the same line. This is still a straight line. So the equation of this whole line is this equation that we know here. So now find the equation of the coordinates of D. So the other thing they said was that AD is the diameter. They said AD is the diameter of the circle. Okay, so we've got points A, we've got C, which is the center. We don't know yet coordinates of C. So let's see, how do we get the coordinates of D? Okay, so
I would say the same as the coordinates for C. I mean for A, because
come again, Ati.
Then I'm asking, isn't the coordinates for D the same as the coordinates for A? Was it they are at the circumference, but they changed the signs because of the different quadrants they are in?
No, they wouldn't be exactly the same, because we are, you see, the center of the circle is not at 0. Remember, our 0, 0 is here, and that's not the center of the circle. The center of the circle is at C. Okay, so it won't be exactly the same.
Yes, ma'am.
Yeah. So let's see how we're gonna get the coordinates of D. Let's see. We don't know the coordinates of the midpoint, but we've got the equation of the line. So, and D is where the circle interacts with the line. Okay, but we don't know the center C. So let's see how this is done. Okay, just give me a moment. Okay, let's see how we're gonna do this. So equation of a line is 2y minus x minus 4. And which is 0. We don't know the coordinates of that. And equation of a circle, we don't know the equation of a circle. It's only coming later on. Okay, let's try the midpoint equation, but we don't know, still we don't know the midpoint of, because the midpoint is C, we don't know coordinates of C. Okay, let's see. Now this I haven't done before. Let's see how this is gonna work. Oh, we don't have a tangent there. Let's see if we use the M for this, gradient for this line is, we found it was half. So let's see if we use y is half x plus c, but still the line is the same. Okay guys, here I will tell you the truth now. I'm lost also. I will need to do this one for you guys and come back to you. Okay. This one, I am lost on this one. Okay, so I will have to come back to you guys. I will do this and come back. And the next questions are gonna be, I will need answers from this one of C, because the next question they say determine the coordinates of C. But we can answer the other ones because I only have the answer for that, not the steps. So coordinates of D was -4 and 0. So I'm just gonna use what is given, -4 and 0. Then the next question, this one I will do it later on. They say determine the coordinates of C. So if we have found the coordinates of D, which I will still figure out, they want coordinate of C. And if you look at DC, they said D, not DC, DA or AD is a diameter. If this is a diameter, that means from the center C to point A is a radius. Also from center C to D is another radius. Therefore, that means C is a midpoint of this line. So if C is a midpoint, the formula for midpoint, it will be your x2 or x1 plus x2 over 2 and y1 plus y2 over 2. Then our x1, x -4 plus the other x is x for A. So we're using D and A. 6 over 2 and the y is 0 plus 5 over 2, which is, sorry, negative 4 plus 6 is 2 over 2, and 5 over 2, 0 and 5, yeah. Therefore, coordinates of C is 1 and 2.5, I think. Okay, I hope that is correct. Let me just see. Oh, I want this bit. Yeah, 5 over 2. So those are the coordinates of C. Okay, so once we got the coordinate of C, they're asking us determine the equation of the circle. So the equation of the circle, we know the formula, the general formula for the equation of the circle. Let me just clear here. Okay, so equation of the circle, you've got x minus a squared plus y minus b squared is equal to r squared. And we said a and b are the center points or the coordinates of the center. Okay, and our a and b, our center point is coordinates of C, which is 1 and 5 over 2. So we can plug them in there. So x minus 1 squared plus y minus 5 over 2 squared is equal to muted. Sorry about that. It's the network and the electricity that is not here. Okay, now we lost that. But the equation of the circle is x minus a squared plus y minus b squared, which is r squared. We had the center, which was C, and C was what? 5 over 2n. Was it 2? Yes. Where are you? 1 and 5 over 2. That was C. So we've got x minus 1 squared plus y minus 5 over 2 squared is equal to r squared. Okay, then we need to find r. R is the distance. Distance formula is ab squared is x minus x, I think, x1 minus x, or x2 minus x2. Let's see again. What is that distance formula, guys? Y minus the other y, so it's y. X doesn't matter, so it's y. 2 minus y1 squared plus x2 minus x1 squared. Okay, so AB squared is y2. We had R, which was between C is 1 and 5 over 2, and the other one was A, which is 6 and 5. Okay, so our circle was like this. Okay, this was A, this was D, 6 and 5. This was the center C. We found the values to be 1 and 5 over 2. D, this is what? D. Then that one at the top is B. This was B. Okay, so we want R. R can be A, C, which is this, or CD. So I'm using AC. So Y2, let's just say Y2 is A. So we have 5 minus 5 over 2 squared plus 6 minus 1 squared. 5 minus 5 over 2, this is the same as 5 over 1. So we've got over 2. 2 times 5 minus 5. Is that true? Yeah. Squared plus 5 squared. Negative 2. No. This is 2 times 5. 10 minus 5, which is 5. So we have 5 over 2 squared plus 5 squared, which is 25 over 4 plus 25. Let's add this one. 4, 25 minus plus 4 times 25, which is 4 times 25 is 100. So we've got 125 over 4. Therefore, AB is square root of 125 over 4, which is 5 over 2. That's our R. It's the same as R. So we're going to come back here and put our R. R squared, which is 1. R squared is 25. Wait, guys. Square root of 125 is not 5. Guys, just let me.
I was still looking for my calculator.
Okay. So that's not 5 over that. This is, okay, let's just leave it as a square root of 125 over 4. The bottom one we know is 2. Okay, so our R squared is this. So this is going to be 125 over 4. Let me just check if we've got the same answer with them. Yeah. Okay. So that equation of the circle is x minus 1 squared plus y minus 5 over 2 is equals to 125 over 4. That's the equation of the circle. Okay. Then the last equation, the last question is determine the equation of a tangent passing through point A. So tangent passing through point A, that will be the tangent. They want the equation of this tangent. Okay, so equation of a tangent, we said a tangent is always perpendicular to the radius. Remember that even when you do your Euclidean geometry, tangent is always perpendicular to the radius. That means they form a 90-degree angle. Okay, so let's see. They want, the last question, they want equation of a tangent. Of the tangent that is through, don't mind my handwriting if you see me for the first time, through A, which is 6 and 5. Okay, so tangent is always perpendicular to that. And if we have perpendicular lines, their gradient, when you multiply them, the product of their gradient is -1. So we already know this equation of this line, right? Equation of line AB. Equation of line AB, we had calculated it, it was 2y minus x minus 4 is 0, which is 2y is x plus 4, divided by 2, divided by 2, y is half x plus 2. So m was half. Then we said m for the tangent times m of, I'll say CB or CA is going to be equals to m of the tangent. Supposed to give us -1. M of the tangent, we don't know. That's what we're looking for. But the m of CB, we know is half, must be -1. Then, for us to get m of the tangent, okay. Right, let me try to connect with my other phone, but I'm not sure how much data do I have in that phone. Okay, it's connected. Let's hope it's gonna push us. I'm not sure if it's got enough data, this phone. Let's see, hopefully, and it won't cut us out. Okay, let's see. Where were we? We were determining the gradient or the equation of a gradient. So that m of a tangent times half supposed to give us -1. So for us to get the m of the tangent to be alone, this side we multiply by 2, multiply by 2. So gradient of that tangent is -2. Okay, then y is equals to mx plus c, which is y is -2x plus c. We need to get the value of c. Let's use the point. That equation was the gradient at the points 6 and 5, which was point A. So we take this value, substitute them in this equation to get the values of c. So we've got 5, -2 times 6 plus c. C will be 5 plus 12, which is c is 17. Therefore, that equation of a gradient will be -2x plus 17. Let me just check the answer. Yes. Okay. So that is it. The other one, the other question, I will figure it out later, where we're supposed to determine the coordinates of this point. I will figure that one later, and then I will WhatsApp you guys. Okay. So that is it. Besides that one that I couldn't figure out, that's how you answer your analytical geometry. Let's move to Euclidean. Okay, so analytical is not a lot of things. Now let's move to Euclidean. Okay, Euclidean geometry, I'm not gonna rewrite. Let me see if I can open my pictures here. Let me just minimize. What can I minimize? Can minimize. Let me open these things for now. Let's see if the pictures I want are here.